I'm back with a new video. In this video, we will try to learn all the major fundamentals and concepts of Angular. So if you are new to the channel, make sure to check other tutorials on my channel. I mostly create content on web development, especially technologies like React, JavaScript, machine learning, and more. So if this interests you, hit that subscribe button to become a member of the channel. So without further ado, let's get started with Angular. So Angular is a front-end development framework for developing single-page applications using TypeScript and HTML. Now Angular is a framework that lets you build dynamic web applications with amazing and sleek-looking user interfaces. So in this complete video, we will learn about the individual building blocks that makes up an Angular application. Now let us see some of the salient points about Angular. So with Angular, you can develop across all platforms. You learn one way to build applications with Angular and reuse your code and abilities to build the apps for any deployment target. Then we have speed and performance. You can achieve the maximum speed possible on the web platform today, and we can take it further via web workers and server-side rendering. It also heavily relies on Observables and RxJS, which we will also see in this video. Next, we have incredible tooling that is available with Angular. So it builds features quickly with simple declarative templates. So in Angular, we follow the declarative style of writing our code. We can extend the template language with our own components and use a wide array of existing components. Now, lastly, it is also loved by millions. So from prototype through global deployment, it delivers the productivity and scalable infrastructure that supports Google's largest applications. Now without further ado, let us see how we can set up an Angular app. So let us click on Get Started. Now to set up an Angular application, we need the official Angular CLI for setting up an Angular project. Now this Angular CLI is the most recommended way of creating Angular projects. We need a complex build workflow for creating Angular applications, and this is what we get from the CLI. The CLI does all of this magic under the hood and also adds optimizations to our code so that we can ship a lean yet optimized code base on deployment of our Angular application. Now for this CLI to work, you need an extra tool, that is Node.js. Now Node.js, as we know, is a JavaScript runtime, but Node.js is what is going to get used under the hood by the Angular CLI. With Node, we get the package manager npm, using which we can install additional dependencies that our framework may need, something we will see later in this video. So make sure to download the latest version of Node.js as well onto your system. So install this LTS version onto your system. Now once you are done with the installation on Node.js, then in order to set up an Angular project, you need to run a couple of commands. So the very first step is to install this Angular CLI. I won't be running this command because I will be using Code Sandbox for demonstration purposes and all. But if you want to follow along with me, then head over to Code Sandbox and use the Angular Sandbox. If you do want to install Angular onto your system, then follow these commands. Now once the Angular CLI is installed onto your system, to set up a new Angular project, you would need to run the command ng new and the name of your project, so which in this case is my app. So for the video, you could say ng new Angular course. Now once you are done with the setting up of your Angular project, in order to start the local development server for the created project, you would first need to change the directory to the created project. So cd my app, and finally you need to run one last command, which is ngserve, to spin up the local development server. So once you are done with setting up of your Angular project, you can then follow along with the video. So as I just mentioned a while back, I will be using Code Sandbox for this video. So on the Code Sandbox, click on this Angular Sandbox. Now this gives me a quick starter Angular project. So let us quickly go over the folder structure that we get with the Angular boilerplate project. So here inside the src folder, we have this app folder where we can define or house all our components for the application. So currently we have only one component, which is this app component.ts. So this is the TypeScript file for our app component. So if you have worked with a technology like React, you would definitely be knowing about components, but for those of us who don't know what a component is, A component is just a reusable piece of code which represents a small part of our user interface and is used in the composition of UI of the application that we create. Now each Angular app that we create can contain a number of such components, and this is what represents the UI of our Angular app. Now to understand other things, we first need to understand how an Angular application actually gets bootstrapped in the browser. Now the content that we are having here, as you can see, can be changed by going to the app component HTML file, and in here we can add some text. So let us say h1 hello world. So you can see the same gets reflected in the browser too. Now at this point you must be wondering how the local development server or the server hosting our application know that it should render the content of the app component HTML. So let's understand how this all works under the hood. So this is not the file that is served by the server, but instead we have an index.html file, which is this one, and this is the file that is served by the server. If you recall, in the very start of the video, I told you that Angular is used to create a single page application. So I was referring to this single page which gets served by the server. Now if we have a look at this file, you can see that this is a normal HTML file, so nothing Angular specific here. But then we have this body of the HTML file, which is what represents the interesting part. We have this app root thing. Now this app root that you see here is not one of the default HTML elements, but instead it is one of the components that we got from the scaffold. We will see how we can create components in this video, but this component is the one that the CLI created for us. Now this in essence is the root component of our application, which in turn will nest other components to represent the UI for our entire application. Now all the files that you can see here are related to this app-root or app root. Now let us have a closer look at the app component ts file. Now here you can see we have this component decorator, but more importantly we have this app root selector, which is exactly the same selector that we have in our index.html file. So right here. So the selector in the app root represents the app component, and the template for this app component is simply the content that we have inside our app component HTML file, which for now just says h1 hello world. So whenever we kickstart our Angular application, the first file that gets executed is this main.ts file. So here you can see we have a couple of imports inside our main.ts file, but the most important thing is this line, which bootstraps our Angular application by passing the app module. So app module is basically this file. Now here also we have this decorator thing. More on this I will discuss later. So here you can see we have this bootstrap. So here we specify all those components which should be known to Angular so that it can bootstrap those components into the browser DOM. It is then Angular comes to know about this app component file and also the selector app root, which comes from right here, and the template is this one. So it is here Angular inserts the app component, and it happens to have a template which we define in the app component HTML file. So this is how an Angular application gets loaded in our browser. Now with this out of the way, let us discuss about what components are in detail and discuss the anatomy of an Angular component. Now as I mentioned just a while back, the components are reusable pieces of code, files here, which are used to compose our entire application. Now in essence, these are the building blocks of any Angular application. We start with the app component, which represents the entire application in the end. Now it is this app component to which we later nest our other components to compose our user interface for an Angular application. So a typical Angular application may look something like this. You can have a main header component. Then we can have a sidebar component. a main content component. Then beneath this, we can have a footer component. So the final UI of your pages of your Angular app totally depends on the placements of these components. Now splitting up of your Angular application into separate components depends on what you want to create, and this is what we will see a bit later in the video. Now a key point to make a note of is that each component has its own template, which is defined by the HTML file, its own business logic, which is defined in the TypeScript file, and its own look, which is defined by the CSS file. So now we know what a component is. Let us create one for our application. So back to Code Sandbox, let us create a component and name it as user details. So inside the app folder, let us create a new directory and name it as user-details. Now inside this folder, I basically want 3 files. So one for the template, so user-details.component.html. So this is the naming convention that you have to follow. Next we need a TS file, so user-details.component.ts, and a CSS file, user-details.component.css. So one is for the template of our component, which is the HTML file. Next we have one for business logic of our component, so user-details.component.ts, and lastly we have one for CSS, user-details.component.css. Now let us add some content to our user details template. So let me copy the code from app component TS, this one, to the user details.component.ts file, and change all the references that says app to user details. So let me select them real quick. User details, and here let us say user details component. Remove this hyphen root from here. Now here we have the selector for this component as user-details. The template is there in user-details.component.html file, which is this one, and the CSS is there in the user-details.component.css, and the name for the component is user-details component. So this is the file where we house the business logic for the user details component, which currently we don't have. So now to render the user details component within our app component, we need to do a couple of things. First, we need to import the user details component inside the app module TS file. So here, let us add the import user details component from /user details/user details component, like this. And then we need to add the user details component to the declarations array. Now lastly, we need to go to our app component HTML file and add the selector, which is this one, user-details. So right here, let us add a div, and inside this div, let us say user-details and close this. Okay, so there is a typo. This should be user instead of uses. Okay, so we are getting nothing because there is no content in our user details. So let us add a p element and say user details loaded. So now you can see we are getting user details loaded in the browser. So this is how we can create a basic component. We will soon sprinkle some business logic in our components. So this we will see a bit later. So now you know how you can nest a component inside another component. Let us move forward to understand more on Angular. Now let us see how styling works in Angular. So styling is kind of super simple here as well. So let us say I want to center the content of the user details and give it a card look. So here let us remove this and add a div with the class of card. And here let us say h1 name colon Alex and p Angular developer living in the beautiful city of Manchester. And now let us head over to our user details component CSS and add some styles to our div. So to the div with the class of card, let us give a box shadow. So box hyphen shadow. So let me paste some styles for the card look real quick. So we are giving a box shadow and a padding of 20 pixels all around. So this is what we get. Now let us move forward to the concept of string interpolation in Angular. Let us say in the user details component, we don't want to hard code the name and the city like we are doing currently, but instead we want to make it dynamic. So for this, we first need to go to our TS file for the user details, and inside it, let us prepare a couple of variables. So let us say one for name, one for city, and set this to Manchester. Set the name to Alex, and let us add one for profession. So set this to Angular developer. Now to be explicit of the type of the variable, we could use the TypeScript feature. So right after the name of the variable, add a colon, and here it is a string. For city also it is a string, so colon string, and for profession string as well. Now let us head back to the template for this component to see the string interpolation in effect. So here we first need a placeholder for name, profession and city. So instead of hard coding the name, profession and city as we are doing currently, we can use this special mustache syntax. So double curly braces, and inside these braces we can specify the name of our dynamic variable, or more specifically the property of our component TS file. For me it is name. So now you can see we are getting Alex from there, and here I can say profession, and here let us say city. So you can see we get the same thing, and our app still works. So any expression that resolves to a string in the end can be used with this interpolation syntax of double curly braces, and this is also called as the mustache syntax. Now let us talk about property binding in Angular. So property binding here is a concept which you can use to bind a property to some property of a DOM element. So let us head over to the docs to understand this in a bit more detail. So here let us search for property binding. So here the first line mentions that property binding in Angular helps you set values for properties of HTML elements or directives. So directives is something we will see a bit later, so no worries for now. So a couple of things that you can do with property binding are toggling a button, setting the paths programmatically to name a few, and also sharing values between components. And this is something we will see in this video as well. So let us see an example for property binding in Angular. So back to the user details component HTML file. Let us add an image and set the src to this URL. So http://randomuser.me/portraits/min/1.jpg. So this gives us a random user image. Now currently we are hard coding it. Now to make the src attribute dynamic, we can bind this to a property that I will define in just a minute in our user details TS file. So to make it dynamic, we can wrap the src attribute in square braces. And let us set this to a property user avatar. So back to the component TS file. So let me first copy this entire URL. So user avatar. Now back to our TS file. Let us define a property. So this would be a string. So user avatar string, and set this to this URL. So you can see this works. Now here in essence the square braces that we are using right here indicates to Angular that we want to dynamically bind some property. So here we are dynamically binding the src attribute to user avatar. So here we are dynamically binding to the src property which this native image element has. For more examples, I highly recommend you to check out Angular docs. The link for the same explaining the property binding can be found down below in the description section of this video. So now let us move forward to the next topic, which is class binding. So to see class binding in action as a very first step, let us add a couple of styles to our user details component file. So the CSS file. So let me quickly copy paste those styles down here. So we have 3 styles and we are targeting the class of Angular, Vue and React, and we are using these colors. Now back to the component TS file, let us create a new property down here and let's name it as is Angular developer of type boolean and set this to true to begin with. Now to see class binding in action, let us wrap this profession interpolation first with a span element. So let me cut this, add a span and then paste the interpolation right inside the span. And let us use the class binding on it, so we can again make use of our property binding syntax that we learned just a while back. So add a class attribute and wrap this with square braces. Now on the class attribute, you need to use the dot operator and specify the class you want to apply subject to the truthiness of the condition that I will specify in just a minute. So class dot Angular. So I want to give the Angular class. So this class needs to match whatever we have in our CSS file. And now bind this to a boolean property if Angular developer. So if someone is an Angular developer, we want to give this span a class of Angular. And this gives us a red shade, as you can see. So now you can see this works and we are getting the profession in red shade. Now let us see this one more time. So let me cut this image and paste it right above the H1 element. Now beneath this P element, let us add another P element. And here let us say nose React. And then let us add a span element. And here again I will make use of the property binding syntax. So class dot, and this time I will add the class React and bind this to a boolean property that I will define in just a minute. So let us name it as React knowledge, and then inside the span element, so within the opening and closing tags for the span element, let us make use of the string interpolation syntax and check if React knowledge is true, then display yes, else display no. So now let us go back to our component TS file and add a boolean property React knowledge. So right down here, this should be of type boolean and set this to true to begin with. So with this in place, let us give this a preview so you can see this works. Now let us move forward and learn about event binding in Angular. So let us see how we can react to events in Angular. So let us say we have a button and on the click of it, let us say I want to toggle the boolean variable React knowledge. So to do that, we can use a special Angular syntax. So first we specify the parentheses. And here in between the parentheses, we have to specify the name of the event that we want to listen to, which in our case is the click event. Now this event binding syntax can be used for any of the possible events that you might be aware of from your JavaScript knowledge. And now within the double quotes, we need to specify the code that we want to run once the click event occurs. So let us define a method for this and name it as toggle. Now make sure to add the invocation parentheses at the end of the method name. Now back to our component TS file. Let us define this toggle method down there. So here let me say toggle. So all we have to do here is to basically refer the React knowledge property using the this keyword. So within the toggle method, this dot has React knowledge. So remember we are in the class here and set this to a bank and this dot has React knowledge. So here we are inverting the boolean state. So if it was true earlier, then we are setting it to false, else we are setting it. So you can see this works. Now as a side note, if you have a single line of code to execute, then you could do that in the template itself right here. But if you have more lines of code to run, then using a method makes more sense. So as a rule of thumb, don't write too much of logic in your templates. Don't pollute them with a lot of logic. Now as a next example, let us see how we can pass events. Now on the div that we have inside our user details component template, let us listen for the mouse move event. So to do that, we need to use our event binding syntax. So parentheses, and we are listening for the mouse move event. And once that happens, let us run a method on update coordinates that I will define in just a minute. Now right inside the div, let us add an h1 element and interpolate the x coordinate and the y coordinate properties. Again, we will define them in just a second. So back to our component TS file, let us add the two properties x coordinate and y coordinate, both of which will be of number type. So set this to 0 to begin with, and y coordinate of number type as well, set this to 0. Now we need to define a method on update coordinates, and this will receive the event object. So let this be of type void. Now we also need to use $event here, which is a reserved word you need to use in the template when working with event binding. So back to our component template file. Here let us pass it right here, $event. Back to our TS file. Here we are receiving the event object. Now in order to get access to the coordinates that we get on the mouse move event, we can make use of the client X and client Y properties on the event object. So let us set our X coordinate. So this dot X coordinate, set this to event dot client X, and the Y coordinate. So this dot Y coordinate, event dot client Y. So now with this in place, let us give this a preview. So you can see this works just as expected. Now let us move forward to the concept of two-way binding. So two-way binding is kind of a combination of the event and the property binding that we discussed thus far. Now to understand this, let us add an input field to our user details component right below our P element. And here I will combine both the bindings. So first the property binding, which we represent using the square braces. And then within these square braces, we need to use parentheses. Now within the parentheses, we specify a special directive. Now in order for this to work, we need to add the forms module in our imports array that we have in the app.module.ts. So right here, let us import the forms module, import forms module from @angular/forms. And here in the imports array, let us add the forms module. So more on directives we will learn later, so no worries for now. So the directive that we need to use here is the ngModel directive. So here let us say ngModel. Now this ngModel directive got unlocked right after importing the forms module and registering it within our application in the imports array. Now we need to set this to some property that we define in our TS file. So let us say verification status. So let us add this property to our TS file as well. So let me copy this. So verification status of type string, and let us set this to empty quotes to begin with. And now let us head back to our template, and here what I want is that if the user types verified in our input field, then this should show verified in green shade, else it should show not verified in red. So for this, let us add some styles. So right here, let us target the elements with the class of verified and give a color of green. And let me copy this and paste it down below and change the class name to not verified and give this a color of red. Now back to our HTML file. So let us add a P element down below our input field, and here let us first give a class of not verified to begin with, and then use the property binding syntax and give a class of verified if if the verification status includes the word verified, so verification status dot includes the word verified, and the verification status does not include the word not, so double and not verification status includes not. So if this condition is true, that the verification status, so the value inside the input field contains the word verified and not contains the word not, then we say verified, else we say not verified. Make sense? So for this, we can use the string interpolation syntax and again use the same condition that we are using for the verification class, for the verified class, and paste it right here. So if this condition holds true, we say verified, else we say not verified. So to see this in action, let us type something in our input field. So if I type some random words, then it says not verified, else if I type verified, it says verified. Now here let me cut this and paste it down here, and if I type verified, you can see this works. And now if I add the word not right after this, it turns to not verified from verified. Make sense? So this works fine. So this is two-way data binding in action. So what essentially happens here is that on the input event, the verification status property gets updated in our component automatically. On the other hand, this also updates the value of our input element if we change the verification status somewhere else. So in essence, with this bidirectional mapping, we are able to feed the values that the user types in our input field back to the property, and then the same values can be pulled from the property to the input field. So this is how two-way data binding works in Angular. Let me also explain this with the help of a diagram that you can find in the docs itself. So this is what represents our two-way data binding. So whatever value the user types in the input field that is there in the template of our component is fed to the property that is there in the component using the event binding, and the same values that are there in the component can be pulled from the property to the input field using the property binding. So this is how this bidirectional mapping works in Angular. So back to where we were. Now we know what two-way data binding is. Let us move to the next important concept, which is about directives. Now directives is one of the most important building blocks that you will pretty much use in every Angular application that you build. They are kind of markers on a DOM element that instructs Angular to use additional behavior to the elements that we define in our component templates. Now even the components that we have seen thus far are kind of directives because we use their selectors to render them in different places of our application. So components in the end are directives with a template attached to them. Now let us see a couple of directives in action. So let us use the first directive, which is ngIf, and this directive can be used to perform conditional rendering. So let's say I want to conditionally render the user details on the click of the button. So the idea here is that on the first load of the component, I don't want to show the user details card, but as soon as the user clicks on show details, it is then I want to render the user details. Make sense? So to do that, we will make use of the ngIf directive. So as a very first step, let us go right inside our component TS file and add a property to our component. Let's name it as show user details and set this to false to begin with, because we don't want to render the user details in the start. Now back to our template for the component, we can use the ngIf directive on our div element. Now as a side note, these directives are added as attribute selectors on our elements. So back to where we were. Now to specify the directive, we first type asterisk, which indicates that this directive that we are going to define in just a minute is a structural directive. A structural directive is a directive that changes the structure of the DOM. So with ngIf, we mean that it either adds the element to the DOM or removes it completely from the DOM based on some conditions that we give to ngIf. So ngIf. Now within the double quotes, we need to place our condition. So here we need to specify a Boolean expression based on which Angular will decide whether to render it in the DOM or not. So here let us set this to our boolean property that we define in the component ts file, which is show user details. So right here let us add the button which says show user details, and here on the click of the button let us call the method, or let us use a single line, show user details, and set this to a bank show user details. So on the button we are registering a click listener using the event binding. So on the click of button we run this line of code that toggles the show user details boolean property from true to false and vice versa. So with this in place, if I now give this a preview, you can see this works. So using the ngF directive, you either render the element or remove it completely from the DOM. It doesn't hide it or sets the visibility property to false. Either it shows the element in the DOM or it removes it completely from the DOM based on some condition. I hope this makes perfect sense. Now here let us make use of the string interpolation syntax. So here let us check for show user details property. So if it is true, then say hide, else say show. So currently it says show, click on it. Now show user details is true. So on the ngF we have true, and this gives us the div in the DOM as you can see. If I click on hide, it turns to false. So this div gets removed from the DOM and we are only left with this button which says show, because the show user details boolean is now false. Now we also have an alternative to this syntax. Sometimes we don't only have the if condition but also the else condition. So let us see an example for that as well. So let me comment this first and add a p element down here, and here let us place our ngF directive asterisk ngF, and let's check if the verification status doesn't include the word not. So not verification status dot includes not. So here we are using a bank, so the verification status should not include the word not, and the verification status includes the word verified. Then render this h1 element to the DOM, else don't put it on the DOM. So to represent the else case, let us make use of a local reference on the ng template element. So right down below this p element, I can add a ng template element. Now think of the local reference as a simple marker, which we'll discuss more later in the video. So let us name the reference as not verified. So to mark a reference we need to use hash not verified. Now here we need to do a simple thing. We need to add an else clause right here and simply point to the reference which is not verified. So if this condition is true, then render this thingy, which is what we specify right here. So if this condition holds true, we render verified. Let's add a class of verified here. And if the condition is false, then by the local reference, this ng template will get rendered, because this is what we specify in the else clause of our condition. And here we can add an h1 element and add a class of not verified, and here let us say not verified. So if I now give this a preview and click on show, we get the card, and if I type here verified, it turns to verified. If I say not, so it says not verified. Let's replace this p with an h1, click on show, it gives us not verified. Say verified, turns to green, not verified, or any random characters will give us not verified. Now we just discussed about structural directives. We also have other type of directives which is known as attribute directives. Now these directives do not add or remove elements from the DOM. They only change the element they are placed on. The link for an article explaining the attribute directives can be found down below in the description section of this video. Now let us see yet another but super important structural directive, which is ng-for. Now in order to demonstrate this, let us say we have a couple of programming languages that the user knows and we want to render them in the template. So for this we need to first manage them in form of an array. So right inside the component ts file, let us create a new array and let's name it as programming languages. And set this to Python, JavaScript, C++, TypeScript. Now in order to render them in our template, we need to go back to our component HTML file. Now right below the ng template, let us use a OL element. And inside the OL element, let us add an li. Now on the li, we again use the asterisk. So this asterisk, as we know, is placed on a structural directive. So ng for. So this is also a structural directive. So within the double quotes now is where we specify the syntax for ng for. So first we need to define a temporary variable just like we do in a normal for loop. So feel free to use any name of your choice. So let's use the name. So let. So we use the let keyword and we say p language of programming languages. So here programming languages is the property that we defined in our TS file. Now this will now cycle over all the elements that we have in our programming languages array and assign each individual element to this temporary variable, which is p language. Now this temporary variable can then be interpolated in the template using the string interpolation syntax like this. Now one quick note here, you can also access the index of the current iteration. So for this, let us go back to our template and right here, let us add a semicolon after the array name, and to capture the index of the current iteration, we can again make use of a temporary variable. So use the let keyword and let us name the index as I. So set this to index and let us also interpolate it right inside here. So put a comma and say I. So let us give this a preview in the browser. If I click on show, you can see that here is a list of programming languages that is getting rendered in the browser. So Python index 0, JavaScript index 1 and so on. So this was all I wanted to cover about the ng-for directive. Now as a very next step, let us cover one of the most important topics of Angular, which is component interaction. So here we will learn how we can pass data between components. So we can pass data both ways using some very special decorators that we will cover now. So the two decorators that we need to understand here are the @input decorator, @input, and @output decorators. So this I will show you in the TS file where we will be using them. And using these two decorators, we can perform the component interaction both ways, from parent to child and from child to parent. So we will see this in just a minute. So these decorators can be used to send data between components and to receive data in form of events. So let us see how we can make this work. To see this in action, let us use the composition concept on the user details and create a couple of such user details cards for each of the users. To see this in action, let us use the composition concept on user details and create a couple of such user details components that we will configure from outside. So for this, we would first need to define an array of users in our app component. So let me remove this title property. And let us add an array of users. So let me copy paste the array of users real quick. Let me uncomment this. So each user will have a name, age, profession, user avatar, a couple of booleans like whether the user is an Angular developer or not, whether the user has React knowledge or not, and whether to show the user details or not. Lastly, we have this array of programming languages for each user in our users array that represents the programming languages known to a user. Now as a next step, let us iterate over all these users that we have in our app component TS file, and for each user that we have, let us generate a card for each of these users that represent all the details for the user. So for this, head over to the app component HTML file and let us make use of the ng-for directive to cycle over all the users. So here put an asterisk ng-for let user of users. and for each user we want to funnel down a couple of properties. So a couple of properties need to be funneled down to the user details component, which is this one, from the app component, right? Now this is what we achieve using the @input decorator. Now as a side note, if you are familiar with React, then this same concept comes under the name props. So place ng for directive on the user details selector and then use a temporary variable to reference the user each time we go over the list of users. So let user of users, and then to pass dynamic data down to our user details card, we can make use of the property binding syntax. So just to recap, I discussed that property binding is used to bind to our properties that we define in a component. So here we say square braces. And then what we want to bind this to? So we want to bind this to the current user that we get on each iteration. So this is the current user. Let me copy this and add it right here. And let us use the property name as user. So here we are trying to configure our user details component from outside by passing the user data, right? So if we give this a preview, currently you can see it doesn't work. Now comes the main part. So head over to the user details component TS file, and in here we need to use a special decorator that Angular provides, and it is the @input decorator. So here let us import input from Angular core, and then to use it, here let us say @input and then the parenthesis. So in essence here we want each user to be available to the user details component. So for this we are using the decorator @input, and now here let us say user. So now we are successfully binding the user property from outside. Now as a side note, you can also use an alias for binding. So I can use the name some user like this, and then this name can be used right here if we want. So let me revert back and remove this. So using the alias you will be able to bind the user via the alias if you want. Something not super important, but of course something that you can do. So now inside our template for the user details component, we can access all these properties, namely the name on the user data that we got from outside, so user.name, and here we can say user dot is Angular developer, user dot profession, then user dot city, and here the check should be user dot has React knowledge, user dot verification status, and here as well. And here we need to iterate over the user's programming languages, and then down here user.show user details, and here as well. So now you can see we are getting two show buttons for each of our two users that we are managing in the app component TS file. So let us click on this one. Okay, so this is not working as you can see. Here we need to add user.show user details, right? And now if I click on show, this gives us the first user, and if I click on show for the second card, this gives us the second user with the name of scene, Vue.js developer, living in the beautiful city of Los Angeles. And if I say verified here, then you can see for this we get verified, and for this it still stays not verified. So you can see everything works. If I click on toggle, it works, and here as well. Now let us see how we can pass the data other way around, so in the other direction, from the child component to the parent component. So essentially the child component in our case is the user details component, and the parent component is the app component. Now if you can see here, we have our input field which is for the verification status. Now for this input field we need to pass some information from the user details component to the app component. So this information is the user verification status. Currently we have two-way binded the user verification status on this input field, but now I want to pass this information up from the user details component to my app component where we want to use this information to update the verification status of the user. Now currently you can see the app component is our central place where we are managing all the list of users. So now to inform the parent component, we can use a custom event. So let us go to our app component HTML file, and here let us name the event that I will emit in just a minute as verify event. So here use the parenthesis verify event. So here we are listening to this custom event on our user details component, and once that happens, let us call a method that we will soon define. Let us name it as update verification status. So to this method, let us pass the emitted event, which we can reference under the special reserved name $event. And also let us pass a second argument, which is the current user that we get from the corresponding iteration. So comma user. So this is not the complete picture, but just half part of the game. As the very next step, we need to emit this custom event from our child component TS file, so which is our user details component. So right inside the user details component TS file, we need to emit this verify event. Now here we need to mark the event that we want to emit. So to create an event, we first need to import the event emitter class from @Angular core. So right here, let us add an import for the event emitter class. So here let us say verify event. Now as a very first step, let's first find the user whose name matches with the current user's name. So the current user that we are getting as the second argument. So let's make use of the find method on the users array. So this dot users dot find, and for each user, and here we want only the user whose name matches with the current user's name. So user dot name triple equals current user dot name. So let us store the returned user in a variable, and let's name it as obtained user. Now as the next step, we need to update the obtained user's verification status to the verification status that we got as the emitted event data. So obtained user dot verification status. Set this to verification status that we receive as the first argument. So with this in place, let us give this a preview, and you can see that on entering verified in the input field, this turns green and shows us verified. So we are passing the data, the verification status, successfully up to our app component, and then updating the user's verification status, which then gets reflected in the UI as new values that were passed down from app component to the user details component. I hope this makes perfect sense. Now as a next step, let us define the code for toggling of the user details. So for this, let us first go right inside the user details component TS file, and in here, let us again make use of the event emitter class to create an instance of event emitter. So let me copy this and paste it down below, and name this as toggle event. And the data that I will be emitting will be an object, more specifically a user object. So instead of string, let us change this to object. So you could definitely be a bit more specific here, but I will go with just object. Now here again we are making use of the @output decorator. So don't forget to add the invocation parenthesis right after the @output keyword. So this one. So now on the click of this toggle button, I want to run some code. So let us define a method, and let's name it as on toggle user details. On toggle user details. And here I just want to emit the user as the payload up the component tree. So this dot toggle event dot emit this dot user. So here we just want to emit the user as the payload up the component tree. So with this in place, let us go to our app component template, and here we will listen to the toggle event. So parenthesis, and within it toggle event. And once that happens, let us run a method toggle user details that I will define in just a minute. And here we need to pass our custom event like this. Now back to our app component TS file, let us define the toggle user details method, and this will receive the user object for which the button was clicked. So let us name the argument as current user. Now inside this method, let us first find the user from our users list whose name matches with the name of the user for which the button was clicked. So this dot users dot find, for each user we are looking for a user whose name matches with the name of the current user. So let us store this in a variable const obtained user. Now for toggle, all we have to do is to invert the show details property on the user that we got by applying the find method on our users array. So obtained user dot show user details equals to a bang obtained user dot show user details, like this. Now here we need to call this method inside our user details component HTML file. So right here. So if I now click on show, this gives me the template for our user details. If I click on hide, it hides it. Let us quickly summarize what we learned up till this point. So we have these two decorators that we can make use for communication between components, the @input decorator and the @output decorator. The @input decorator allows us to configure our properties from outside, and then we have the @output decorator that allows us to emit a custom event that we can create using the event emitter class and pass on data from the child component to some parent component. So if your chain of components is not that long, using the @input and @output decorators would be fine in such cases. Later we will see how we can use services in those cases where the component chains are pretty longer than the one that we saw in this simple example. Now let us move forward to the concept of life cycles in Angular. So whenever a component is created, Angular goes through a series of life cycle phases that represents the component life cycle from a component creation to its destruction. So the idea here is that with these lifecycle hooks, we can tap into one of these phases and run some code. So let us understand them in detail. So the first phase that we can tap into is the ngOnChanges hook. So this hook is executed right at the start when a component gets created, and then thereafter it also gets executed whenever one or more data bound input properties change. So namely the properties that are decorated with the @input decorator that we covered. Next we have the ngOnInit hook, and this gets called when the component is initialized. So this hook gets called once right after the first ngOnChanges. So by initialization, it doesn't mean that the component has been mounted to the DOM, but it means that the properties can be accessed and initialized. ngOnInit runs after the constructor that we define in the TypeScript class. Next we have ngDoCheck. Now this gets called immediately after ngOnChanges, so on every change detection run. Now this method will get triggered every time there is a change detection. Now this change detection is something by which Angular detects changes in its template, so something that is part of the reactivity system of Angular. Next we have the ngAfterContentInit lifecycle hook. So this gets called after the content, so the ngContent has been projected into the view. Now right after it we have the ngAfterContentChecked lifecycle hook. So this gets called every time the projected content has been checked. So this hook gets called after the ngAfterContentInit hook and every subsequent ngDoCheck lifecycle hook. So you can see it is mentioned right here. Next we have the ngAfterViewInit lifecycle hook, and this gets executed once the component and all its children views have been initialized. Right next to it we have the ngAfterViewChecked. So this gets called after the ngAfterViewInit and every subsequent ngAfterContentChecked. Now lastly we have the ngOnDestroy hook, and this gets called immediately before Angular destroys the component. So this is a very fitting spot to perform the cleanup. So unsubscribing to observables and detaching event handlers to avoid memory leaks in your application. So basically for releasing the allocated resources of a component, if any. So let us now see these lifecycle hooks in action. So let us head back to our user details component file and define a constructor function here. So constructor console.log user-details constructor got triggered. Next, let us add the lifecycle hook ng-on in it. So for this we need to implement an interface on our class. So let me add it real quick. Implements on init, and let us import it from @Angular core. So here let us add the ng-on init lifecycle hook. And here let us log to the console user details ng-on init got triggered. So if we give this a preview, you can see first the constructor runs. So a new instance of the component gets created, and then after that we get the log for ng-on init got triggered. Now we also have the ng-on changes lifecycle hook. So let us implement that as well. So right here let us add the ng-on changes. Now in order to unlock this lifecycle hook, we need to implement the onChanges interface. So let me add the import for it from @Angular core. So remember to implement the interfaces which these methods require. So here for this we need the onChanges interface, just like we had one for the ng-on init, which is on init. Now the ng-on changes hook receives an argument, and this is the changes argument of type simple changes. So make sure to import it at the top from @Angular core. Now let's log the changes that we get to the console as well. So console.log changes, and then console.log user-details ng-on changes got triggered. So if we give this a preview, so you can see first we get the logs of the constructor. So constructor got triggered 2 times because we are having 2 instances of user details component. Then you can see ng-on changes got triggered. For the change we get the user object, which is our bounded input property, as you can see here. Now if you check this changes object, we get the previous value for this property, which is undefined in our case. Then we have this current value, which is our user input, and then there is the first change property, which is set to true because yes, it is our first change. Next we also have a couple of other lifecycle hooks that you can try on your own. The link for an article explaining more on these lifecycle hooks can be found down below in the description section of this video. But there is one specific hook that I would like to cover before we wrap up with these lifecycle hooks. So it is this ng-on-destroy hook. So let us see this in action. Let us go back to our app component TS file and add a button. So back to our app component HTML file. Let us add a button down here, down below where we are rendering all our user details instances. So on the button, let us add a click listener. And once a click event happens, let us call the method hide everything. So let us pass the event like this, hide everything. Now right inside our component TS file, let us first add a boolean property and let's name it as should display, and set this to true to begin with. So if the should display property is true, then we will show all our user details cards that we have for each of our users, else we won't show them. Now let us add our hide everything method, and here we need to do one simple thing. We just need to set the show display property to false. So this dot should display equals to a bang this dot should display. Okay, so we don't want to toggle it. So set this to false in order to hide everything. Now finally we need to add an ngIf on our div and set this to should display. So right here add an ngIf directive and set this to should display. So the idea here is that on the click of the button which says hide everything, we want to unmount all our user details instances on the click of this very button, and this should cause a trigger of the ng on destroy lifecycle hook that we can tap into. So let us tap into the ng on destroy lifecycle hook. Now inside our user details component ts file, let us implement the on destroy interface and let us implement here as well. So on destroy. Now let me copy this real quick and paste it down below and change this to ng on destroy, and inside here let us log to the console cleanup time. So with this in place, let us give this a whirl, and if I now click on this button, it hides both the components. You can see we are getting two logs which says user details cleanup time. So this clearly verifies that the ng on destroy hook got triggered for each of our two user details components on the unmounting of these components. So for each of these users, the user details component got unmounted from the DOM, and hence the ng on destroy hook got executed for each one of them. So this was all I wanted to cover about the lifecycle hooks. Let us advance further with Angular. Now let us proceed with our next topic, which is services. Now if you are familiar with the previous version of Angular, which was AngularJS, then you must be knowing about services, but let us quickly recap. But for those of you who are new to Angular, so in simple terms, if you find duplicacy in your code and data storage, then consider using a service. So if you want to run the same logic for a couple of components, then outsourcing that logic in a service can be considered. So let's see what a service is. A service is a class of this form. So it is a class just like a component and is considered as a central repository where we can house some of the business logic of our application. So it is kind of a centralized entity where you can place some of your business logic that is commonly required in a lot of components of your application. Now before we start working with services, I would like to fix this here. So currently you can see for both the cards we are having the same user avatar. So let me change this to user.userAvatars. So the user that we are getting from outside, and access the user avatar property on that. So now if you see this, we are now getting two user avatars that are different, right? And let me comment all this as well, because these things we are getting from outside and each user have these properties. Now not this, let me uncomment this, and even this as well, because now we are using our events to toggle the user details. Now let me remove this old functionality as well, this toggle, and this button which runs the toggle method, and even this as well. Now let us see how we can create a service. So let us go right inside our app folder and create a new file, and let's name it as dataservice.service.ts. Now here let us export a TypeScript class. So export class data service. Now as we learned a while back that any class becomes a component when we attach the add component decorator to it, but here we don't use any directive for defining a service. A service is just a plain TypeScript class. Now here let us define a simple method that returns us the list of users that we are currently managing in the user details component ts5, and let us simply centralize the logic for accessing it in the service. So let us grab the list of users that we are currently managing in the app.component ts file. So let me cut this and paste it right here. And now let us define a method in our service, and let's name it as getAllUsers. And here let us simply return this dot users like this, or just return a copy of this. So this dot users dot slice. Next we need to use this service in our components, right? So here I need to use the service inside app.component.ts file. Now to use the service, we need to understand how Angular allows us to access our service. So you could argue that if we just create an instance of our service class and then use it, it should work, right? Of course it does work, but there is a better way that Angular provides. So let us see that now. Now Angular offers us a tool using which we can access our services. The tool that Angular gives us is the dependency injector. So let us search for it right here, dependency injection. So here you can see it says DI is wired into Angular framework, and we can use it everywhere to provide new components with the services or other things they need. So these components consume services. So what we do here is that we inject a service into a component, giving that component the access to that service class. So a dependency in our example would be the user details component depending on our data service for the users array. So using a dependency injector, we can inject an instance of our data service class that I will be defining in just a minute into our components automatically. So let us first understand what a dependency injector in Angular is. So Angular dependency injector is our main mechanism here that creates an application-wide injector for you during the bootstrap process, and some additional injectors as well. You don't have to create your own injectors. So what the injector is, it's a hierarchical injector, which means that if we provide a service in some place in our application, so say some component, then via this injector, Angular knows how to provide an instance of service to this component and all its child components. So all the child components of this component will receive the same instance of the service. Now as a side note, if you provide a service in the app.module.ts, then that same instance of service will be made available to our whole application. So to the entire component tree and to all the services directives that we create. So let me demonstrate this with the help of an example. So on the top is our app module. Then we have our app component. Then let us say our user details component. And then let us say the user details component also has some child components of its own. So if we register a service in the user details component, so right here if we do a registration, then that same instance of service will be available to all the children of the user details component. So the same instance is being provided to all these children components of user details component. Next, if we register our service in the app component, then the same instance of service will be available to all the children of the app component, so to the user details component and all its children. Lastly, if we register a service at the module level, so right here, then all the components within that module will be able to use the same instance of the service. So let us see this in action as a very first step. Let us go to our component.ts file where we want to use the newly created service. So it is our app component.ts file, and here let us add our constructor method. Now here we need to use an instance of our service class. So let us say private data service and then colon. So right after colon we need to specify the type. So the type here is the class that we want to inject into this component. So it is our data service. So data service. Now make sure to import it at the top. So import data service from dot slash data service dot service. So this sets up an instance of the data service which we can now use inside our app component TS file. Now as a next step, we also need to provide this service before we can use it. So right inside the add component decorator for our app component TS file, add a property providers. And here we need to simply pass an array. Here let us add the data service because it is this service that we want to provide to our component class. Make sense? So in essence, with this dependency injection, we are not manually creating an instance of the data service, but instead Angular does that for us. So let us get our users array into our app component TS file now. So right here, let us define a users property inside our app component TS file and set this to an empty array. Now inside the constructor, let us access our data service and get all the users. So this dot data service dot get all users. So let us set the returned array to our users property. So this dot users like this. So with this in place, let us give this a preview and you can see everything works. Now if for example, you want to call the service method from some other class, then the same procedure has to be followed. Step 1 is to go right inside the constructor method of a component, add an instance of that service class as an argument. Also, you need to provide the service to the component by passing a provider's property to that component's add component decorator. Make sense? Now, if you see it clearly, we are providing a service in our app component. So this very instance, this same instance will be made available to all the components that come under the component tree with root as our app component. Now as a next step, let us cover the next important topic of observables. So let me head over to the docs to understand what an observable is. And we will understand this in the context of HTTP because this is where Angular's subscription model comes into picture. So from our knowledge of web development, we know that a real-world application needs some data from an external data repository. So typically a database. For this, our Angular application needs to interact with the server APIs to fetch relevant data that is needed. Now there are two ways we could consume this data. Either we could use promises or an observable. So let us first understand the difference between an observable and promise. This distinction itself will explain the definition of an observable. If you don't know what a promise is, check out the promises video of my JavaScript series. The link for the same can be found down below in the description section of this video. So a promise is something that you get when you make an async HTTP call to the remote API. The idea here is that when you request the data from an API, you don't get the data immediately. Instead, this fetching logic runs asynchronously. So it typically takes a couple of seconds before we get the final data. So this is where promises comes into picture, where we handle this single event of completion or failure of an async API call. Now contrary to this, we have an observable. And I know this might be new to some of you, but an observable is a stream of values. So the idea here is that observable allows us to pass 0 or more events, and for each such event, the callback function gets triggered. Now another difference between promises and observable is that observables are cancelable. So by cancelable I mean that if the result of an async API call or any other expensive operation is not required anymore, you could clear the subscription that you set up for the observable. Now on the other hand, a promise will always eventually trigger the success or failure callback even if the result it gives us is not required anymore. So this is something that you should keep in mind while working with observables and promises. Now the third difference that I would like to cover here is that a promise is something that gets executed immediately. So let me clear up some space. So promises and observables, so they are executed immediately. Contrary to this, an observable only starts when you subscribe to it. Starts only when you subscribe to it. And it is due to this very reason observables are called lazy. Now there are a couple of operators that observable provides, and this is something we will see throughout the video. So this is it regarding what an observable is. So let us see the concept of HTTP and observables in action. Now to make an HTTP request with Angular, we don't need any third-party package, but instead Angular ships with its own HTTP solutions that we can leverage for making an HTTP call. So one module that Angular ships with is the HttpClientModule. So let us go back to our application and make use of this HTTP client. So right inside our app module TS file, import HttpClientModule from @Angular common HTTP. Now the next step is to add the HTTP client module in our imports array. So right here, HTTP client module. So now with this added, we can now start sending requests to some API. For this demonstration, I will be using the fake JSON server API to fetch a list of to-dos. So let's go right inside our app component TS file and inject our HTTP client service in there. So next to our data service injection, let us add one for HTTP client, private HTTP client of type HTTP client. So make sure to import it from @Angular common HTTP. So this was the first step. Now to fetch the list of to-dos from the JSON placeholder API, we first need to set up an ng-oninit lifecycle hook. So for this, right here, let us import the interface on init and implement it on our component. So implements on init. And right here, let us add the ng-oninit lifecycle hook. So here I want to make an async API call on the component initialization. So make sure to import the oninit interface from @Angular core and implement oninit. Now right inside our hook, let us make use of our injected HTTP client service. So this .http client, and on it we have the get method. Now this takes on a URL that we want to target, which in our case is https://jsonplaceholder.typicode.com/todos. Now to get informed about the response, we need to subscribe to the observable that this API call returns. Now if we don't subscribe to the observable that gets returned, then our request will not be sent, because Angular knows that if we are not using the response or consuming the data that we requested for, then making the API call is of no use. So this is unlike promises where the execution happens immediately. Here, unless you subscribe, the request won't be made. Make sense? So here we need to subscribe. So to subscribe to the observable that gets returned, we need to make use of this special subscribe method, and in here we get our to-dos. And let us just log them to the console to see what is in there. So console.log to-dos. Now one interesting thing about observables provided by Angular is that the subscriptions to Angular observables automatically unsubscribe when they are not needed without having us to manually do it. So here you can see we are getting the array of to-dos from the fake JSON API. So each to-do has these 4 properties: user ID, ID, title, and completed. Now next, let us see some RxJS operators that we can use to transform the response data that we get from the API. So the process here is that we tap into different steps through which our data funnels through before it reaches our subscribe method. Now before we actually subscribe, let us chain a pipe method right here. And you can see this pipe returns us an observable to which we can subscribe. So we need to make use of the pipe method that allows us to funnel our observable data through a set of operators before they finally reach this subscribe method. Now we also need the map method that is used to perform the transformation of the data and then wrap it back to an observable so that we can later subscribe to it. So right here, let us add the map method. So here we need to import map from RxJS/operators. So this map method in turn takes a function. So let us use an arrow function, and here we will receive our to-dos response data. So in here, let us create an empty array of modified to-dos. So const modified to-dos. Then let us use a for-off loop and go over all the to-dos that we got in our response. So for const to-do of to-dos, and let's modify each to-do a bit by adding a date added property to each of our to-dos. So modified to-dos dot push, and use a new object, and let's spread all the properties that we have on the current to-do, and then we add a new property to each of our to-dos. So this new property is date added. So set this to new date dot to locale string, and finally let us return our modified to-dos array like this. So return modified to-dos. So the map method will make sure that the modified to-dos array gets wrapped in an observable so that we can later down our chain call the subscribe method and log the to-dos to the console. Make sense? Now one thing more, if I hover over this, you can see to-dos arrays of type any. Now the reason for this is that TypeScript here does not know the format of our response data. So as a very first step, let us add an interface for our to-do. So let's name this as todo.interface. So let's create a new file inside our app folder, todo.interface.ts. So here let us export an interface to-do. And here we will have a user ID of type number, an ID of type number, a title of type string, a completed property of type boolean, and an optional date added property. So question mark string. So now we are done with our interface file. Let us import the interface right at the top in our app component TS file. So import todo from /todo.interface. So first thing first, to-dos array will be of this type, to-do. So we set the type to to-do square brace here as well. And with just these simple changes, you can see we get better auto completion in our IDE as well. And here also you can see now we are getting the value as to-do array. Now there are a couple of other requests that you can make with this HTTP client, like post, put, delete and more, that you can easily try doing on your own, because now we know how we can send requests using the HTTP client. As a next step, you can also add a separate standalone HTTP service where you can then inject the HTTP client to perform API calls. So you can house all your HTTP related logic in that single centered file and then inject the HTTP service file or the newly created service in the components where you want to make your API calls. Something you can definitely try on your own from the knowledge that you have gained till this point. Now I forgot to cover the concept of error handling in HTTP requests, so let us cover that now. So this subscribe method that we have here can take more arguments as well. So let us add the second argument. So the second argument is a function that gets triggered whenever an error is thrown, and it is here we get our error object. So let us print the error to the console if one occurs. So console.log error. Now to render the error that we get in our template, let us define a property in our TypeScript class, and this will be a Boolean property. So has errored, and set this to false to begin with. Now if an error occurs, let us set this to true. So this dot has errored to true. Now back to our component template, let us render an h1 element right below our button and place an ng if here. So if has errored is true. Let us render the text to-dos could not be fetched due to some reason. Now you can also be more explicit here and make use of the error object to frame your error. That is how you do error handling with your API calls. So let us see this in action. Let us commit a small typo here in this URL. So now you can see we are getting our error. To-dos could not be fetched due to some reason. And you can also make use of this HTTP error response to extract the error that it gives and render that instead of this. Make sense? So let me revert back. Now here also, if you examine the structure of the data that you get from the API call, we have this extra property to each of our to-dos. So this map operator did work, right? Now let us see the last way of performing error handling for your API calls. Now there is an operator that RxJS provides us to perform error handling, and that is the catch error operator. So let us import it at the top of our app component TS file. So catch error. Now to use this operator, we again need to go to our pipe method, and right after this map operator, add a comma. Let us now add our catch error operator. So catch error, and this receives an error object. So the same error that we get in the second argument of the subscribe method. So you can send any error here to some error logging service if you want, or do some generic error handling here. So for simplicity, let us just log the errors to the console. So console.log catch error, error occurred, error. Now next we need to import the throw error function from RxJS. So import throw error from RxJS, and this is what will give us an observable wrapped with the error that we get. So let us throw our error wrapping observable that we get from this throw error function like this. So return throw error and pass the error to it. So if I hover over this, you can see it gives us an observable, right? So it emits no item to the observer and immediately emits an error notification, right? So make sure to return this. If an error occurs, it will then be able to reach our subscribe method. So you can see this works. So this is it for the section on observables and HTTP. Let us move forward to the concept of pipes in Angular. Now pipes is a feature that is built into Angular, which basically allows us to transform the output in our component templates. Now Angular provides pipes for different types of output, synchronous and asynchronous data. So let's learn about some built-in pipes of Angular. So I'm back on the Angular docs for pipes. Let us have a quick glance over the documentation. So these are some of the built-in pipes that Angular ships with. The date pipe, which formats the date value according to the locale rules. Uppercase pipe to transform to uppercase. Lowercase pipe to transform to lowercase. Then we have the currency pipe, decimal pipe, percent pipe, and so on. So we have tons more pipe, and for a complete list of built-in pipes, you can check this link. So let's first use the uppercase pipe to convert the name of the user in our user details component to all uppercase. So back to user details component, HTML file. So right here we are rendering the name of user within the curly braces. So add the pipe symbol, which is this standing line, and just say uppercase like this. And if we now give this a preview, you can see the name of the user is all in uppercase. So here we are not inherently changing the name property of the user. We are just transforming or presenting the name in uppercase in the template. So our focus is just on the template side here. Make sense? Now you can also apply other pipes in similar manner. You can even chain these built-in pipes like this. So if you are rendering some variable or property and you want to apply a couple of pipes on this, so pipe 1, then pipe 2, then pipe 3, and so on. You can apply pipes to a property, and all these pipes will then get parsed from left to right and will get applied in the same order. The link for this page from the Angular docs on pipes can be found down below in the description section of this video. I strongly encourage you to try these out yourself. Now back to where we were. Let us now see how we can create our own custom pipes in Angular. Now sometimes we need a functionality that is not built in. So for this we can create our own pipe to achieve that functionality. So let us create a custom pipe to filter the programming languages that the user knows based on the search term that the user enters in an input field, which I will render right here. So let us go right inside the template for the user details and add an input field where we can specify the search term, and based on that search term we will show only those programming languages for the user that contains the search term that we specify. Make sense? Now here right above this OL tag, let us add the input field, and here use ng model, set, and add a placeholder search. Now make sure to import the forms module from Angular Forms for this two-way data binding to function. Now back to our user details component HTML file. Here is our input field. Now imagine instead of this we have a long list of such languages. So with this input field, whatever search term we specify here, we want to show only those languages that contains that search term and hide others which don't contain that search term. Make sense? Now let us create a new file for our custom pipe, and let's name it as filter.pipe.ts. So right here, create a new file, filter.pipe.ts. So let's add a class here, and this class needs to implement a very special method so that we can sprinkle the functionality that we want to our custom pipe, and this method is the transform method. So export class filter pipe transform, and this class needs to implement the pipe transform interface. So right here, implements pipe transform. Now make sure to import the pipe transform at the top from @Angular core. So import pipe transform from at Angular core. Next, we need to implement this transform method inside our class. Now this transform method expects a value, so let's name it as items of type string, so an array of strings. So it expects a value that is to be transformed. You could give this any name of your choice, but I will go with the name items because here I expect to get an array of items on which we want to apply the filtering logic. Next, I also need a search term as the argument based on which I want to filter the items. So search term of type string. Now from this pipe, we need to return something. So something that we get on applying the transformations that we specify in this transform method. So that something will be an array of strings as well. So here I'm using colon and the type that will get returned from this transform method. Now as a first step, if the array of items is empty, then let us simply return an empty array. Next, if we don't specify any search term, so if no search term, then we don't want to perform any transformation on the items that we receive right here. So for this, let us simply return the items as it is. So return items. Now if we do have a non-empty list of items and there is a search term in the input field as well, it is then I want to filter based on the search term. So on the items array, so return items, and on the items array we can make use of the filter array method, and for each item we first convert it to lowercase, and for each item of our items array we check whether each item does contain the search term that the user specifies. So dot includes search term dot to lowercase. Now make sure to apply the to lowercase method both on the item and the search term in order for this to work correctly. Now this file lacks one important thing. We need to add a special decorator, the add pipe decorator, which we can also import from at Angular core. So import pipe, and here let us add our add pipe decorator. Now here we need to specify a name for our custom pipe by simply adding a name property. So let us give this a name filter. Now to use our filter pipe, first we need to import the filter pipe class in our app module ts5 and add it to the declarations array that we have there. So import filter pipe from filter.pipe, and here in the declarations array let us pass the filter pipe like this. So now with this in place, as the final step, let us use it in our template for the user details component. Now right where we are rendering the programming languages for the user, let us use the pipe symbol right within the quotes for ng4, and here we need to specify the name of our custom pipe, so filter. Now to pass an argument, we can use the colon and pass the argument search term like this. Now make sure to add a string property search term with an initial value of empty quotes to begin with in the component ts5. So right here, search term colon string, set this to an initial value of empty quotes. So with this in place, it should work. Let us give this a whirl. JavaScript, this works. If I just say script, this works. Python, so you can see this shows only the list which contains the search term Python in it. So this works great. So we have successfully implemented a custom pipe that can be used for filtering. So let us now move forward to the concept of forms in Angular.